NEC Article 702.6 specifies the location requirements for a transfer switch in relation to the service disconnecting means. The article states that the transfer switch must be installed on the load side of the service disconnecting means. This requirement is in place to ensure that the generator and the normal utility power are properly isolated during operation and maintenance. Let's delve into the reasons behind this code requirement. Firstly, placing the transfer switch on the load side of the service disconnecting means ensures that when the generator is running, the utility power is completely isolated from the generator circuit. This prevents the possibility of backfeeding power onto the utility grid, which could be dangerous for utility workers and could also damage the generator and other electrical equipment. Secondly, this configuration allows for safe maintenance and repairs to be performed on either the generator or the utility service without the risk of energizing the other source. By disconnecting the service disconnecting means the entire load side, including the transfer switch and the generator, is de-energized from the utility. Similarly, by disconnecting the generator disconnecting means the generator and its associated circuits are de-energized. Thirdly, this arrangement simplifies the wiring and control of the transfer switch. With the transfer switch on the load side, it can directly switch between the utility power and the generator power without having to interrupt the service conductors. This reduces the complexity of the transfer switch and makes it easier to install and maintain. It's important to note that there may be specific exceptions or allowances for locating a transfer switch on the supply side of the service disconnecting means, but these are typically limited to situations where the transfer switch is specifically listed as service equipment and is designed to meet all the applicable safety requirements. However, in general, the NEC requires that the transfer switch be located on the load side to ensure safe and reliable operation of the generator system. When installing a transfer switch, it's crucial to consult the manufacturer's instructions and the applicable electrical codes to ensure that it is installed correctly and that all safety requirements are met. It's also important to properly size the transfer switch and the associated wiring to handle the full load of the generator and the connected circuits. Ignoring these requirements can lead to serious electrical hazards and equipment damage. Furthermore, understanding the proper application of NEC Article 702.6 is crucial for electrical engineers, electricians, and anyone involved in the design and installation of generator systems. By adhering to this code requirement, it is possible to ensure the safe and reliable operation of the generator system and to protect both people and property from electrical hazards. In summary, the NEC mandates that the transfer switch be positioned on the load side of the service disconnecting means for a multitude of safety and operational reasons. This configuration prevents backfeeding, facilitates safe maintenance, and simplifies wiring. While exceptions may exist for listed service equipment, compliance with Article 702.6 is paramount for the integrity of generator systems. When selecting a location for the transfer switch, it is also important to consider the environmental conditions. The transfer switch should be installed in a dry, well-ventilated location that is protected from extreme temperatures and humidity. This will help to ensure that the transfer switch operates reliably and that its lifespan is not shortened by exposure to harsh conditions. Additionally, the transfer switch should be installed in a location that is easily accessible for maintenance and repairs. This will make it easier to troubleshoot any problems that may arise and to perform routine maintenance tasks such as cleaning and inspecting the contacts. It's also important to consider the noise level of the transfer switch when selecting a location. Some transfer switches can be quite noisy, so it's best to install them in a location where the noise will not be a nuisance to occupants of the building. Furthermore, the transfer switch should be installed in a location that is secure and protected from unauthorized access. This will help to prevent tampering and vandalism, and to ensure that the transfer switch is always available when needed. When installing a transfer switch, it's also important to consider the grounding requirements. The transfer switch should be properly grounded to ensure that it operates safely and that it does not pose a shock hazard. The grounding conductor should be sized according to the applicable electrical codes and should be connected to a reliable grounding electrode system. In addition to the grounding requirements, it's also important to consider the bonding requirements. The metal enclosure of the transfer switch should be bonded to the grounding electrode system to ensure that it is at the same potential as the ground. This will help to prevent voltage differences between the enclosure and the ground, which could create a shock hazard. When selecting a transfer switch, it's important to choose one that is listed by a recognized testing laboratory such as Underwriters Laboratories or Canadian Standards Association. This will ensure that the transfer switch has been tested and certified to meet the applicable safety standards. It's also important to choose a transfer switch that is compatible with the generator and the electrical system. The transfer switch should be rated for the voltage, current, and frequency of the generator and the electrical system. It should also be able to handle the full load of the generator and the connected circuits. When installing a transfer switch, it's important to follow the manufacturer's instructions carefully. The instructions will provide detailed information on how to install the transfer switch safely and correctly. It's also important to use the correct tools and equipment when installing the transfer switch. This will help to ensure that the installation is done properly and that the transfer switch operates reliably. After the transfer switch has been installed, it's important to test it to make sure that it is working correctly. The test should verify that the transfer switch can switch between the utility power and the generator power without any problems. The test should also verify that the transfer switch is properly grounded and bonded. Regularly scheduled maintenance for the transfer switch is paramount. This involves inspecting the switch for any signs of damage or wear, cleaning the contacts, and tightening any loose connections. Regular maintenance will help to ensure that the transfer switch operates reliably and that its lifespan is extended. The NEC provides comprehensive guidance on the selection, installation, and maintenance of transfer switches. It's important to be familiar with the applicable NEC requirements when working with transfer switches. The NEC requirements are designed to ensure the safety and reliability of electrical systems. Transfer switches are essential components of backup power systems. They provide a means of automatically or manually switching between the utility power and the generator power. Transfer switches are used in a wide variety of applications, including hospitals, data centers, and emergency response facilities. The type of transfer switch that is used will depend on the application. Some transfer switches are designed for automatic operation, while others are designed for manual operation. Automatic transfer switches will automatically switch to the generator power when the utility power fails. Manual transfer switches require an operator to manually switch to the generator power. Transfer switches are available in a variety of sizes and ratings. The size and rating of the transfer switch will depend on the load that it is intended to serve. It's important to choose a transfer switch that is properly sized for the application. Transfer switches are typically installed in electrical panels or enclosures. The transfer switch should be installed in a location that is easily accessible for maintenance and repairs. The transfer switch should also be protected from moisture and other environmental factors. Transfer switches are an important part of any backup power system. They provide a means of ensuring that critical loads will continue to be powered in the event of a power outage. When selecting and installing a transfer switch, it's important to follow the applicable electrical codes and standards. This will help to ensure that the transfer switch operates safely and reliably. In addition to the NEC, there are other codes and standards that may apply to transfer switches. These codes and standards may vary depending on the location and the application. It's important to be familiar with all of the applicable codes and standards when working with transfer switches. Transfer switches are constantly evolving. New technologies and features are being developed all the time. It's important to stay up to date on the latest developments in transfer switch technology. This will help to ensure that you are using the best possible transfer switch for the application. Transfer switches play a critical role in ensuring the reliability of electrical power. They are essential components of backup power systems. By understanding how transfer switches work and how to install them correctly, it is possible to ensure that critical loads will continue to be powered in the event of a power outage. So remember, Article 702.6 of the NEC dictates the placement of the transfer switch on the load side of the service disconnect, ensuring a safer and more reliable generator operation.